Okay, we're going to be looking at the Newman projections here of pentane, and we want to look at the Newman projection of pentane about, about the carbon-2, carbon-3 bond. So if we were to show that we wanted to visualize this, we would want to visualize this in the carbon-2, carbon-3 bond, the sigma bond. I'm going to redraw this as the carbon-2 and carbon-3 as a tetrahedral structure, and then we'll get started looking at the Newman projections. Alright, so I've drawn carbon-2 and carbon-3 as a tetrahedral. Sometimes I'll give you the plane structure. I'll just give you the structure I just boxed right there. And sometimes I'll actually give you the tetrahedral structure. But I want to show you how you can go from here to here. So from just a regular condensed structure or an expanded condensed structure to the tetrahedral. So we're looking here at carbons 2 and carbons 3. And if you look at carbon 2, we're showing the tetrahedral of it. We're showing the carbon-carbon bond here is this carbon-carbon bond in the plane, right? So what are the other 3 bonds to carbon-2 that are on the left-hand side here? Well, we notice this carbon here is bonded to 2 hydrogens and a CH3 group. So I'm just going to write those on the second carbon. And I'll just write them anywhere. I'm going to put the CH3 group at the top. For this compound, it doesn't matter. And then I'll put the 2 hydrogens in front and in back here at the bottom. Alright, now we want to do the same thing with carbon 3. Carbon 3 here, what is bonded to it? I'm going to use a different color. Well, we see that there's 2 hydrogens bonded to third carbon besides the carbon-carbon bond. And there's also this group here, which I'm going to call an ethyl group. Because that's what it is. Alright, so let's put the ethyl group, the CH2, CH3, up here at the top. Well, once again, we'll just put our 2 hydrogens here. Now, sometimes I will, or the book will give you the 3-dimensional structure that we just drew here, and sometimes it will just give you the name of the compound or the condensed structure is here. So I want you to be able to do the Newman projection of each. So we want to look at, once again, the Newman projections of pentane through the carbon-2, carbon-3 bond. So that's how we've set it up here. So when we do that, if we look at how it's situated right now, and we're looking from the perspective I just mentioned, we're going to start our Newman projection. And notice I put the front carbon with one of the bonds up, and that's because the CH3 group on carbon-2, this is carbon-2 we're drawing here, is up. So I'm going to put the CH3 up. And then from this perspective, the 2 hydrogens here are on the right and left. Alright, that's the carbon-2. In the back we have a carbon-3. Now notice the ethyl group here, the CH2CH3 group, is in the plane with the other carbons. So the perspective I've drawn it here, that conformation is that the CH2, CH3 group, which I know this is messy the way I've drawn it, I'm going to go back. Okay, there we go. CH2, CH3. That might look a little better. It's hard to do with my finger. So everything here is on the plane. Every carbon's on the plane. The hydrogens are in the plane. So everything is on the plane here. And what we said we called this compound was an eclipsed conformation, right? This is an eclipse conformation because of all the bonds on top of each other. Right here, what we notice are the CH3 group and the CH2 group, CH3-CH2 group, the methyl and the ethyl group, are the largest groups. And when the largest groups are eclipsing each other, we call this total eclipsed. Alright, now we want to know what the other Newman projections are. So we hold one of the carbons steady, and we start turning the other carbon, either the front or the back, 60 degrees. And every time we turn it 60 degrees and come up with a new conformation, we'll draw it down. So I'm going to hold the back steady, and I'm going to hold And I'm going to rotate the front carbon 60 degrees. So my back is still the same. My front now has changed. So the CH3 is here, hydrogen, hydrogen, and this conformer is called gauche because the two largest groups are 60 degrees apart on the dihedral angle. Gauche. Alright, we can do 60 more degrees, right? Hold the back steady, turn the front 60 degrees. And when we do that, we get an eclipsed conformer again. And this one actually is called eclipsed. I'm going to put ET for ethyl because it's just easier. A lot of chemists do that. Oops. Now we have a hydrogen. The methyl group is here in the front. Hydrogen in back. Hydrogen in back. And hydrogen in front. So this is called eclipsed because now all of the atoms on the front carbon are on top of the atoms in the back carbon. However, now there is a 120 degrees between the two largest groups. So we called this eclipsed. And what we can do is we can draw one more Newman. If we rotate another 60 degrees, remember the back is held constant, so that doesn't change. I'm going to put my ethyl, my hydrogen, and my hydrogen in the back, and we're moving the front. So it went from eclipsed, so now we're going to be staggered again. And now the CH3 is 180 degrees from the ethyl group, the largest group. And when that is the case, we call this staggered inversion anti. So these are the 4 different, you can keep going, you can keep rotating 60 degrees. The front carbon, what you're going to find is at this point, as you keep rotating around, you're going to go back to what you've already done. You're going to go to, when the CH3 is on top of this hydrogen, you'll have eclipsed again, and then you'll have gauche, and then you'll have totally eclipsed again. So these are the 4 conformations. The lowest energy is always the anti-conformation when you have 4 conformer. And the highest energy conformer of the 4 is the totally eclipsed.